there's one important part of introductory trig that we haven't talked about yet. We have talked about right triangles, and we've talked about what to do in the situation where you know one of the angles, suppose you know 30 degrees, you know one of the sides, let's say it's 5 and it's the hypotenuse, and you're trying to find another side, which is x. In this case, we just set up, the first thing we do, step 1, is identify the sides of the triangle. And what I mean by that is identify relative to the angle you're interested in, opposite, adjacent, and hypotenuse. So this is across from the 30 and is the opposite. This is next to the 30, so it's the adjacent. And the reason this isn't the adjacent, even though it's also next to 30, is because it's the hypotenuse. It's across from the right angle and is the longest side of the triangle. And then the second thing to do is choose your function. And in order to choose your function, what you want to do is you're obviously going to use the angle given to you. And then you want to use the two things, one of them that you want, and the other one the side that you're given. So you have to pick two sides. One side should always be x, and the other side should be any other side that you know. So in this case, we know our angle is 30, and the two sides we can pick are x, and this is the hypotenuse. I forgot to label that one, which is 5. So then we look and see, well, which function relates hypotenuse and opposite? And the answer is sine. So we're going to be using the sine of 30 degrees. And we set that equal to the opposite, which is x, divided by the hypotenuse, which is 5. Step 3 is solve. And here, this is where you need to know algebra, and it's very important that you're able to manipulate equations quickly, efficiently, and easily. And to do that, we're going to multiply both sides by 5, and we find that x is equal to 5 times the sine of 30 degrees. And we're all set. So, once you get there, you plug that into your calculator, and you write down your answer. So, things are a little different, because you're not always going to have one side and one angle. There may be times when, for example, you have, let's say, two sides, we'll call them 3 and 4, and you want to find an angle, which we'll call theta. So in this situation, you use the exact same method, but you just solve for theta instead of x. So again, step 1 is identify the sides. Well, this is the relevant angle, so this is our opposite, our adjacent, and our hypotenuse. Step 1 is done. Step 2 is to select which function we want to use. We always want to choose one angle and two sides. So these two sides, since we know them, are obviously going to be the ones we use. And this angle is what we're interested in, so we're going to use that. So we now have to choose our function, as I said, and what relates opposite to adjacent? Well, that's tangent. So then we write it down, tangent, and instead of filling this in with a 30 or a 60 or 45 or something, we are going to put in theta, because we don't know what the angle is. This is what we need to solve for. And this is equal to opposite, which is 3, over adjacent, which is 4. So now we have to solve. That's step 3, is to solve. But how do we solve for theta? Some people think, oh, you can divide by tangent. But this is an operation. This tangent is acting on the theta. Okay? It's very similar to how if you have 3 squared equals 2x, you can't divide by the squared to get rid of it. You have to do a special operation called a square root. And you have to do it to both sides. And when you do that, that gets rid of the square, and you're left with 3 equals the square root of 2x. Similarly, there's a special operation that undoes trigonometric functions. Like the square root, you have to do it to both sides. And when you have a tangent, the undoing special function is called the inverse tangent, or the arctangent. So I'm going to write it the way it's shown in your calculator, even though I personally don't like the notation because it's if you have that, so it's written in tangent -1 of theta, you do it to both sides, so you have tangent -1 of the tangent of theta. And the reason I don't like that is because the -1 typically, something to the -1 power means 1 over that. But here, this is an operation we're doing to something. They use -1 because it's inverse, but I think it's a bit ambiguous. So and that's going to be equal to, you have to do the inverse tangent to both sides. So you have the inverse tangent of 3 over 4. So the inverse tangent of the tangent goes away. And you're left with theta is equal to the inverse tangent of 3 over 4. If you have a graphing calculator and you want to find this operation, typically you look at the button that says tan, and above that, in a different color letters, it will say tan -1. And I forget if there are parentheses there or not, probably not. And to get that, you go in the top left of your calculator where there's another button that says second. Hit second and then hit tangent, and it will activate the secondary function of that button, which is inverse tangent. So then you say, oh, theta, this is the angle we want to solve for, and then you just plug in tangent inverse of 3/4, and you get your answer. You're all set. And then you find your angle. So let's do an example, again, that doesn't use tangent. Let's suppose instead, let's see, I want to do, let's say we put theta up here. Now let's suppose this is 7 and this is 4. Sorry, we're not doing axis. 4. So to do this, we're going to label the sides. Step 1, label sides. Opposite, adjacent, hypotenuse. Step 2, identify which function you want to use. Well, we want to include 2 sides and 1 angle. These 2 sides are given to us. This is the angle we want to find. So we're going to use adjacent and hypotenuse. Cosine relates adjacent to hypotenuse. So we're going to write down cosine of theta is equal to the adjacent, which is 4, divided by the hypotenuse, which is 7. Now, step 3 is solve. So again, if you want to undo cosine, you do the inverse cosine. There's also an inverse sine. So you take the inverse cosine of both sides. So we do cosine, inverse cosine of the cosine of theta equals the inverse cosine of 4 over 7. The inverse cosine cancels with the normal cosine because it's essentially doing the reverse of, if you take an angle and you take its cosine, then you take its inverse cosine, you end up with the angle. So we're left with the angle, and we have the inverse cosine of 4 over 7. And now you just plug this into your calculator, and you're all set. So this is how you can use inverse trigonometric functions to solve for angles that you don't know when you do have 2 or more sides. They can be, it can be very useful in some situations, although most of the time in this physics class we're going to be using normal trig functions and not so much the inverses. But they'll come in handy once in a while. That's how you use inverse functions.